Right, you're joining with the missile paper number 3, the war against yourself, testing your consistency. Actually, I couldn't put the recording of this, the discussion of this yesterday because of some university work. So today I am doing the recording for you right now at 9:39 because I want to complete this within today. So first of all, let's go for the easy questions. That means the statement type questions. So the first one, identify the incorrect statement with regard to thermal decomposition of the salts given below. So there is ammonium chloride, ammonium nitrate, ammonium carbonate, ammonium dichromate. So there are all of these are ammonium salts. So out of them, from ammonium salt decompositions, there are 3 ammonium salts which does not give ammonia, right? So out of them, ammonium dichromate, ammonium nitrate, and ammonium nitrite are there. So out of those 3, there is one ammonium salt which gives a precipitate, Cr2O3, which is green in color. So those kind of things are tested here. So let's see the first one. Only 2 salts give ammonia as a product. So what are the salts that give ammonia as a product? Ammonium chloride, ammonium nitrate will not give. Ammonium carbonate will give. So only 2. That is correct. Only 2 salts will give nitrogen as the product. That's wrong actually. Yes, that's correct. Ammonium nitrite will form and ammonium dichromate will form. So those two will be forming nitrogen. And ammonium nitrate, however, it will form N2O. So this is also correct. Then third one, only 2 of the salts give an acidic gas as a product. Only 2 salts give acidic gas as a product. So yeah, let's see. So ammonium chloride will give ammonia and HCl. And ammonium nitrite, it doesn't give any acidic gas. It will give nitrogen and H2O. Ammonium nitrate will give N2O and H2. N2 and N2O and H2O, right? Yes, N2O and H2O. Yes. So ammonium carbonate will give ammonia and actually H2CO3. Now H2CO3 will dissociate again to form carbon dioxide and water. So carbon dioxide is an acidic gas. Ammonium dichromate, on the other hand, it will form nitrogen, water, and Cr2O3. So acidic gases, what are the acidic gases here? Carbon dioxide is acidic, HCl is acidic. All others are neutral actually. So here you have an answer that is correct actually. Third one is a correct statement. Only one of the salts give products that exist as a solid at room temperature. Only one of the salts gives a product. Yes, that's correct. That ammonium dichromate, that's what I told you. It's the only ammonium salt that gives a precipitate, that gives a solid component. Fifth one, only 2 of the salts give H2O as a product. So there are a lot of, right? 1, 2, 3, and 4. There are 4 actually, which gives water as a product. So this one is the answer. That's the incorrect statement. Second one, third one, fourth one, calculations. Actually, fourth one we can manage to do. Which of the following represents the energy diagram of the reaction H2 gas, Cl2 gas, and HCl gas? Bond energies are given. So if the bond energies are given, what we can do is we can calculate delta H by using that equation delta HD broken bonds minus delta HD formed bonds, right? So broken bonds, hydrogen gas is there, so 430 is there, plus 240 for chlorine, minus delta HD formed bonds. Formed bonds are HCl bonds, so 430 into 2. 2 HCl bonds are there because 2 molecules of HCl are formed. So 430 and 240, 270, 370, 470, 570, 670. So 670 minus 2 into 0, 0, 3 into 2, 6, 2 into 4, 8. So that's gonna be 670, 770, 870, minus 190. Minus 190 kilojoules per mole will be the enthalpy change for this reaction. Ethacota, we can tell that this is an exothermic reaction because the delta H is negative. So final energy should be actually lesser than the initial energy, which will cause it to release the energy, right? So it can't go like this. Can't go like that. Products can't have a larger energy than the reactants. This one also can't be. This one also can't be. So the only possible answer here is answer number 1. That's all you have to do in that question. That's all you have to do in that question. So it's not hard. It's just application of normal chemistry knowledge and some a little bit of common sense you have to have here, right? So yeah. Fifth one. A closed container equipped with a piston contains an ideal gas at temperature T and pressure P1. The volume occupied by the gas is 2 cubic decimeters. When the volume is increased to 5 cubic decimeters at the same temperature, which of the following statements is correct? So when you change the pressure, right? So temperature is kept constant. So volume and pressure is going to change. You are applying the Boyle's law here. So kinetic energy is not changed. Kinetic energy is changing only if you change the temperature. So average kinetic energy should remain the same. So second one, third one, and fifth one, you can just cut off them. So first one and fourth one will be the answers, right? So out of them, we have to select which one. So to do that, we are going to apply Boyle's law. P1 multiplied by 2 is equal to P2 multiplied by 5. Just simple. P1 V1 is P2 V2, Boyle's law. So there we can have P2 is equal to 0.4 P1. So there you go. That's the answer. Answer is answer number 1. Then sixth one, which of the following statements is correct with regard to colors observed for precipitates or solutions when excess sodium hydroxide and excess ammonium hydroxide are added separately to solutions? Each of the following cations, cobalt 2 plus, nickel 2 plus, and copper 2 plus. Right. So cobalt 2 plus gives a brown precipitate and a red solution. So with excess OH minus, right? With excess OH minus, they're asking. So excess OH minus, cobalt will not dissolve, right? Cobalt will not dissolve. It will give a brown color precipitation. Okay, and cobalt 2 plus now gives a pink color precipitate, right? Cobalt hydroxide is formed. So we can take it as wrong. The second one, nickel 2 plus gives a blue color precipitate. So it does not dissolve in excess OH minus. We know it. Nickel hydroxide will be formed and it's a green color precipitate. It's not a blue color precipitate. Actually, it's a green color precipitate. So this statement is wrong. Then part C, copper 2 plus will give a blue precipitate. Right, that's correct. Copper hydroxide and then excess ammonia you add, it's going to form dark blue solution. That's correct. That's correct. Zinc 2 plus will give a colorless solution with excess OH minus. That is correct. And excess ammonia also colorless solution. You can have answer number 3 there. So there was a small issue with my mic. I hope you heard this. Copper 2 plus gives a blue precipitate with hydroxide and dark blue solution is formed with excess ammonia. Excess OH minus blue precipitate and excess ammonia, it's going to form the dark blue. Zinc will dissolve in both OH minus and ammonia. So that is that answer number 3. Boiling point of propanone is less than butane. So propanone, meth, eth, prop. Right, it's a ketone. So the central carbon atom should have a double bond oxygen. So propanone. Right, so propanone is similar to acetone. Actually, this is also called as acetone. So keep that in your mind. This is called as acetone. So this is propanone less than the boiling point of butane. So method prop but. There are 4 carbon as CH3, CH2, CH2, CH3. Right, boiling point of butane. This is butane. So butane contains 4 carbon atoms and there are no dipole-dipole interactions. So this one contains dipole-dipole interactions, but there are no hydrogen bonds. Actually, hydrogen bonds are not formed. So you can tell our acetone has a larger boiling point than what you call butane, right? So less than, that's wrong. It's actually larger. Propanone contains pi bonds, whereas butane does not contain any pi bonds. That's correct, I think. Anyone can understand that. That's answer number 4. Eighth one, electronegativity of manganese is lower than that of electronegativity of chromium and Fe. Yes, manganese has a stable configuration. You're going to learn this in D block. We did this in class. I told you manganese has a stable electronic configuration. Therefore, manganese doesn't need any electron. So the electronegativity of manganese is very less. So this is correct. Electronic configuration. Okay, that explains it. That explains it. So I'm going to go for answer number 1 there. 10th one, increasing order of electronegativity of underlying carbon atom. So this carbon atom here, sp hybridized, this carbon atom sp2 hybridized, right? 1, 2, 3, sp2. This one is sp2. This one is sp3. So there I go, sp, sp2, sp2, sp3, right? So sp hybridized carbon should have the largest electronegativity, of course. Then it can't be answer number 2, answer number 4, answer number 5. So it should be 1, 3, or 4. So out of them, sp2, this carbon should be larger. So we can tell that this should be the least, right? This should be the least. So we can't take the third one also. Third one also can't be an answer. So we have eliminated all second, third, and fifth, right? So we can have, we can compare between these two. So the difference there is, the fluorine atom is more electronegative than chlorine, right? We look at the neighboring atoms, right? We look at the neighboring atom. Fluorine is more electronegative, which gives a more positive charge on carbon, which makes it more electronegative. So here you can go for the answer number 4. You can go for the answer number 4. Okay. So I'll go for the calculation questions now. Not much hard actually. So here, volume of 5 mole per cubic decimeter H2SO4 required to react completely with 20 cubic centimeters of 30% NaOH by mass and density, 1.4 gram per cubic centimeter. Right. So let's first of all calculate the concentration of sodium hydroxide. So concentration of sodium hydroxide will be 30% of 1.4 multiplied by, yeah, now this is the triangle method you have to follow here. Gram per cubic centimeter, you have to convert to mole per cubic decimeter. So grams to moles, you divide by molar mass, right? You divide by molar mass, then you will get mole per cubic centimeter. Then per cubic centimeter to per cubic decimeter, you multiply by 1000. So actually what you do is multiply by 1000 and then divide by the molar mass of sodium hydroxide. Sodium is 23, right? So 24, 30, and 40. That'll be 40. So you'll get the mole per cubic decimeter value here. 2 zeros, and another 0 here. So 15 divided by 2. Right? 15 divided by 2. So if we calculate this, 7.5 multiplied by 1.4. Find for 22 remaining, 7 for 28, 30. Find 1, 5, 7 into 1, 7. Right, so 0, 5, and 10. That's going to be 10.5. This is the concentration of sodium hydroxide. Right, this is the concentration of sodium hydroxide. So now what you can do is you can calculate the number of moles of sodium hydroxide that is reacted. Number of moles of sodium hydroxide will be 10.5 mole per cubic decimeter multiplied by 20 into 10 to the power minus 3. So that's 210 10 to the power minus 3 moles. That's 0.21 moles. So now you know the number of moles of sodium hydroxide. Then you have to calculate the number of moles of H2SO4. So if we write the reaction, 2 sodium hydroxide will react with 1 H2SO4 to form Na2SO4 plus H2O. Right. So yeah, you have sodium hydroxide there. Then you can calculate the number of moles of H2SO4 by dividing by 2 multiplied by half. Sorry, dividing by 2, yes, multiplying by half. Both are same. 0.21 moles. Right. If you know the number of moles, then you can calculate the volume consumed volume of H2SO4, half into 0.21 moles. You divide that by the concentration, 5 mole per cubic decimeter. Moles and moles cancel off, 5 into 2, 10. That's going to be 0.021 cubic decimeters. That's going to be 21 cubic centimeters. Right. So there you go. So you can take a note of this. I'm going to erase this. You can pause the video and look into this. Right, let's look into the third question now. A closed rigid container at room temperature contains equal masses of helium and neon. So mass of helium is equal to mass of neon. Mass we can write in terms of moles, right? Mass is equal to molar mass. Right, mass is equal to molar mass multiplied by number of moles. So this is the equation which you need to use. So I'm going to write number of moles of helium multiplied by the molar mass. Molar mass of helium will be 4, which will be equal to number of moles of neon multiplied by 20. So 4 into 5 actually. So number of moles of helium is equal to 5 multiplied by number of moles of neon. So now they're asking the total pressure is given. They're asking the partial pressure of helium. So to calculate the partial pressure of helium, we have to calculate the mole fraction of helium. So mole fraction of helium is number of moles of helium divided by number of moles of helium plus number of moles of neon. So that's the total number of moles. Right? So number of moles of helium divided by number of moles of helium, which is equal to no, I'm going to separate. Instead of number of moles of helium, I'm going to write 5Ne, right? 5 into number of moles of neon divided by 5 into number of moles of neon plus number of moles of neon. Neon and everything will cancel off. So 5 divided by 5 plus 1 is 6. So 5 over 6. So the pressure of helium will be 5 over 6 into P. Total pressure multiplied by mole fraction. So what an easy question is this? 5P over 6. So there you go. Answer is answer number 2. So with that, the third question is done.